In this video, we want to calculate the upstream pressure. Now, I want to show how to calculate the upstream pressure. Now, for a problem where a pipeline which the MPS is 14, 0.250 inch wall thickness, 40-mile long, transport natural gas, specific gravity is equal to 0.6 and the viscosity is equal to 0.000008 pounds per feet seconds at a flow rate of 80 million standard cubic feet per day at an inlet temperature of 60 degrees Fahrenheit. Assuming isothermal flow and neglecting elevation changes, calculate the inlet pressure required for a delivery pressure of 800 psig. The base pressure and the base temperatures are 14.7 psia and 60 degrees Fahrenheit respectively. Use the Colebrook's equation with pipe roughness of 0.0007 inches. Now, so let's write down the given data. So the given data are, now we have the MPX, that is a pipe size is 14 inches. Let me say D is equal to what? 14 inches. While the thickness of the pipe is 0.250 inches. Now we are given the gas gravity, specific gravity at 0.6. We're also given the viscosity of the gas to be 0.000008 pounds per feet seconds. Now, we're given the flow rate to be 60 times 10 raised to power, 80 times 10 raised to power 6 standard cubic feet per day. So, while the inlet temperature is 60 degrees Fahrenheit, since it is an isothermal process, mainly the temperature remains the same. So we have the average temperature to be 520 degree Rankine. So, and again, the downstream pressure is 800 psig, which is something as 814.7 psia, while the base pressure is 14.7 psia. The base temperature is 60 degree Fahrenheit, which is the same thing as 520 degree Rankine, and the roughness is 0.0007 inches. Now we are asked to calculate what the inlet pressure, or we call it the upstream pressure. So to do that, first we need to calculate the internal diameter. The internal diameter of the pipe is equal to the outer diameter, so minus minus 2t, where is minus 2 times the thickness. So we have 14 minus 2 times 0.25, which will give us 14 minus 0.5. So this is 13.5 inches. That is our D, 13.5 inches. So since we have gotten this, we now have to calculate the Reynolds number. And the Reynolds number for imperial, the formula for imperial unit, that is universal standard unit, so it's 0.00047778 times base pressure divided by base temperature times gas gravity times the flow divided by the viscosity divided by the internal diameter. So this is 0.004778 times the base pressure is 14.7 divided by the base temperature is 520 times 0.6 specific gravity times the flow rate, which is 80 times 10 raised to power 6 divided by viscosity, which is 0.000008 divided by 13.5. So let's make use of our calculator. Let's make use of the calculator to calculate this. Now, so using our calculator, we have 0. We have 0.00047778 times 14.7 divided by 520 times 0.6 times 8 times 10 raised to power 6 divided by 0.000008 divided by 13.5 equal to, so what we have here is 6 million and 3,628.2. So this is our Reynolds number. Now, since we have gotten that Reynolds number, now we need to now use the Colebrook equation to find our transmission factor F. So to get our transmission factor, we now use we now use the Colebrook's White equation, which is F is equal to minus 4 log base 10 bracket open roughness divided by 3.7 divided by internal diameter plus 1.255 times F divided by Reynolds number. So now for us to solve this, let's assume as F is equal to 20. So the assumed value is F subscript A, which is equal to 20. Now we are looking for the value of F. So since F is here and here, we're going to make use of this formula. We are looking for F, F subscript N, which is new, equal to minus 4 log to base 10 E divided by 3.7D plus 1.255 F A, the assumed value, divided by Reynolds number. So this is what we're going to be doing now. Now we're going to be doing an integration until Fn is close to Fa, until they are the same, almost the same value. Then we're going to stop. So what we're going to do now, since we have assumed F subscript A to be 20, so F subscript N, which is the new value, will now be minus 4 log base 10 E, which is the roughness, which is 0.007 divided by 3.7 divided by 13.5 plus 1.255 times 20 divided by 6,003,128.2. Now let's calculate the value of F subscript N. Now to calculate the value of F subscript N, we now say minus 4 times log base 10 bracket open 0.0007 divided by 3.7 divided by 13.5 plus 1.255 times 20 divided by 6,003,128.2 bracket plus to equal to. So what we have as our Fn is now 18.960. So you have Fn to be 18.960. So when you look at it, 18.960 is not equal to 20. So we're going to do another iteration. We're going to now assume the next value of F subscript A will now be 18.960. So we're going to use that. So we look for the next F subscript N, which is equal to minus 4 log to base 10 bracket open, 0.0007 divided by 3.7 divided by 13.5 plus plus 1.255 times 18.960, which is our new assumption. Assumed value divided by a real number, which is 6,003,000 and 3,128.2. So now our F subscript N will now be minus 4 times log base 10 bracket open 0.0007 divided by 3.7 divided by 13.5 plus 1.255 times 18.96 divided by 6,003,128.2 bracket close equal to, so I have 19.369. Okay, the 19.3, sorry, 370. So now we're not going to also assume, is another iteration, but this value is different from this. We're going to assume the F subscript A to be 19.370. Now let's make use of it now to calculate. Now we now need to calculate the F subscript F to be minus 4 log to base 10 bracket open 0.007 divided by 3.7 divided by 13.5 plus 1.255 times 18.960 divided by 6,003,128.2. So this will give us what? So here will now be 19.370. So it will now be equal to minus 4 times log bracket open 0.0007 divided by 3.7 divided by 13.5 plus 13.5 plus 1.255 times 19.37 divided by 6,003,128.2. So So we have here to be 18.973. So it's not still close yet. So now let's also now assume f subscript a to be 18.97973. Now we find f subscript n to be minus 4 log base 10 bracket open 0.007 divided by 3.7 divided by 30 5 plus 1.255 times 18.973 divided by 6,003,128.2. Now let's work this out. Now we have minus 4 times log bracket open 0.0007 divided by 3.7 divided by 13.5 plus 1.255 times 18.973 divided by 6003 128.2 bracket open close equal to, so this is equal to 18.981. So we have here now 18.981. Now let's also, if you look at this 18.981 with this, there's still little difference, still some little difference there. You can say roughly, now I'll stop here because the variations are not much there. So this should be our final value for f, since f n is roughly equal to fa. So our fn will be equal to now 18.981, 18.981. So this is our f. Let me remove this. This is our f now. Our f will now be 18.981. Now, if you look at this, we are not given the z factor. That is a compressibility factor. It's not part of that equation. So for us to solve this, we now have to make use of this formula where z is equal to 1 all over bracket open 1 plus bracket close the average pressure. This average pressure is in gauge times 34440 times 10 raised to power 1.785 times G divided by the fluid temperature raised to power 3.825. Now, since we don't know the value of the upstream pressure, we can now assume our average pressure to be equal to 1.1 times the downstream pressure. And the downstream pressure in psig is 814.7. So 1.1 times 814.7 will give us, let's now we make use of our calculator. 1.1 times 814.7 will give us what? This will give us 896.15 psia. Now, but what we're using here is gauge pressure as the average in this formula. So now we're going to say 896.15 minus 14.7 to give us our gauge pressure, the average pressure of the gas. So now we'll say minus 14.7. So we have 881.47 psig. So now we're going to make use of this to calculate our compressibility factor. So now we know the fluid temperature to be 520 degree Fahrenheit, degree Rankine, sorry, 520 degree Rankine, and we are in this formula we're going to the gas pressure, the average gas pressure should be in Rankine. Now let's impute these our values into this equation to get our the value of our Z. So Z is equal to 1 all over bracket open 1 plus bracket open PGVA as average pressure times 344400 times 10 raised to power 1.785 times G divided by gas temperature raised to power 3.825. So we have 1 all over bracket open 1 plus our average pressure is 881.47 times 344,400 times 10 raised to power 1.785 times G is 0.6 gas gravity divided by 520 raised to power 3.825. So the compressibility factor will now be equal to, we just say 1 divided by bracket open 1 plus bracket open again 881.47 times 344,400 times 10 raised to power 1.785 times 0.6 times 0.6 divided by 520 raised to power 3.825 equal to, so the value of our Z factor will now be 0.0873. So this is our Z factor, 0.873. So this is the Z factor we're going to use to solve for the upstream pressure. So now we're going to go do that. Now we're going to use our general flow equation. So, and we're going to neglect elevation effect. So now Q will be equal to 38.77 times F times base temperature divided by base pressure times P1 square minus P2 square divided by G divided by gas temperature divided by the length divided by Z, all raised to power 0.5 times P internal diameter raised to power 2.5. Now raised to power 2.5. So now we're looking for this. So the other values are given. Okay, let me just, so our flow rate is 8,000, sorry, it's 80 times 10 raised to power 6 is equal to 38.77 times F. Our F is equal to our F is equal to 18 points. Our F is equal to 18 points. From our calculator is equal to 18.981. is equal to 18.981 times the base temperature is 520 divided by the base pressure, which is 14.7, times P1 square minus the base pressure, which is the downstream pressure, which is 814.7 square, divided by G, which is 0.6, times temperature, which is 520, times the length of pipe. The length of pipe is 40 miles, times gas gravity, which is 0.872 is 737, all raised to power 0.5 times D, which is 13.5 raised to power 2.5. Now, to get our P, first let's solve for the whole of this. Let's solve for this whole term that is in brackets. So now, to solve for that, we are going to move the whole of this value here to this side. Now, to do that, first let me say P1 square minus 814.7 square divided by 0.6 times 520 times divided by 40 divided by 0.873. So we want to look for this. So now it will not be equal to this 80 times 10 raised to power 6 divided by this times 14.7 divided by 520 times 1 divided by this value divided by 13.5 raised to power 2.5. So that means this raised to power 5, this raised to power 0.5. So the whole of this raised to power 0.5 will now be equal to this. Now let me write it well so that it will be visible. P1 square minus 814.7 square divided by 0.6 times 520 times 40 times 0.873, all raised to power 0.5 equal to 80 times 10 raised to power 6 times 14.7 divided by 3, 8.77 times, also divide by 18.981 divided by 520 divided by 13.5 raised to power 2.5. We have this. So we are going to multiply both sides by multiply the power of both sides by 2. So if you multiply 2 to this, it will give you 1. So that means you have P1 square minus 814.7 square, all divided by 0.6 divided by 520 divided by 40 divided by 0.873, which will equal to 80 times bracket open 80 times 10 raised to power 6 times 14.7 divided by 38.77 times 8 divided by 18.981 divided by 520 divided by 13.5 raised to power 2.5 all squared. So the whole of these things will now be squared. So now to now have P1 square minus 814.7 square. We'll now multiply both sides with this value, with this denominator value here. So now multiplying both sides by this, we're left with this. So now the right hand side will now be 0.6 times 520 times 40 times 0.873 times bracket open 80 times 10 raised to power 6 times 14.7 all over 38.77 divided by 18.981 divided by 520 divided by 13.5 raised to power 2.5 all raised to power 2. Now it now means that P1 square will now be equal to, if you move this to the side, comes plus 814.7 square plus the whole of this. So now let's calculate the whole of this and see what it gives us. So now let's do that. So 0.6 times 820 times 40 times 0.873 times bracket open 80 times 10 raised to power 6 times 14.7 divided by 38.77 and divide by 18.981 divided by 520 divided by 13.5 raised to power 2.5 brackets close all raised to power 2. So this is equal to 229,000 476.47. Now, if we now add plus 814.7 square we now have, to add that, we now have 893,212.561. Now let's take the square root of that value. The square root, if we take the square root of both sides, we'll now have our p. So p1 will now be the square root of this. So now this will give us 945.099. So it's roughly 945 point. Okay, let me say 0.099 psi a. Now, since we have gotten this, we can now calculate the average pressure, which is, calculate the average pressure. So calculate the average pressure. Which is equal to 2/3 times P1 plus P2 minus P1 P2 divided by P1 plus P2. So since we have gotten our P1, so average pressure will now be equal to 2/3, because we assumed average pressure when we were calculating. So 945.099 plus 814.7 minus 945.099 times 814.7 divided by 945.099 plus 814.7. So let's calculate now. That means we have 2 divided by 3 times bracket open 945.099 plus 814.7 minus 945.099 times 814.7 divide by brackets open 945.099 plus 8114.7 bracket close bracket close again equal to, so we have 881.510 psi. Now, but the average pressure now let's calculate from this. Let's calculate now. Let me look at the average pressure we calculated the other time. We have what? We have 896. Okay, so there's a lot of differences. So now let's go to let's now use this value to calculate our compressibility factor. So this is also the same thing as 881.51 minus 14.7 in gauge pressure. So now, if I minus 14.7 from it, I will now have 866 points. We'll now have 866.810 psig. So now let's make use of this to calculate our Z factor. So Z will be equal to 1 all over 1 plus bracket open 866 points 866.810 times 344,400 times 10 raised to 1.785 times G, which is 0.6, divided by 520 raised to 3.825. Now, let's calculate our Z factor here now. Now, to calculate our Z factor, we have 1 divided by bracket open 1 plus bracket open 866.810 times 344,400 times 10 raised to 1.785 times 0.6 times 0.6 bracket close Okay, now bracket close. Divide by 520 raised to power 3.825. Bracket close. Bracket close. So what we have is 0.874. So we have 0.874. So the former we have Z, the former one was 0.873. So I don't see any difference here. I don't see any difference here. I don't see any difference. So since 0.874 and 0.873, if you look at it, the values are close enough. Very close. So that means the final answer should be that. So this small fraction cannot make any difference. So now there is only calculating. So our P1 will now be this. So that is the final answer. P1 is 945.099 psia. So this is the upstream pressure. This is the upstream pressure. So that is it. Now we come to the end of this video. Please do well to subscribe to my channel and also hit the notification bell so that anytime I make new videos, you'll be the first to see them. Thank you and God bless.